Today, on how it's made. Pro hockey sticks. The puck stops here. Bronze baby shoes. We take you through the process one step at a time. Treadmills. We'll bring you up to speed about how they make them. And handheld computers. Computer processing unplugged. Today's cutting-edge hockey sticks are made primarily of graphite, a strong yet lightweight material woven from carbon. Professional hockey players have their graphite sticks custom-made. Each player has the curve and angle of the blade tailored to precise specifications that he believes enhances performance on the ice. To construct the stick's hollow shaft, workers layer 15 sheets of graphite, each in a different direction, to make the shaft uniformly rigid. Heat-activated resin molds the layers together. This machine, called a flex tester, measures how much force it takes to bend the shaft 2.5 centimeters. If the force is within a certain range, the shaft has the correct degree of stiffness for that model. The blade starts with a plastic core. In the center, there's a piece of hard foam wrapped in graphite. It absorbs the impact of the puck. Later, they'll mold the core to the shaft, but for now, they glue and clamp them together. When the glue dries, they cover the core in a graphite sock. The sock's fibers run diagonally. The fibers of subsequent layers run in other directions, building a combination of crisscrossed fibers that creates uniform stiffness throughout the blade. Now the core goes into a glue applicator. This heat-activated plastic resin permeates the graphite. Once it cures, it'll fortify the material. The next two layers of graphite are strips. On one, the fibers run vertically. On the other, they run diagonally. They're stiffer because they've already had a resin application. They run through the glue applicator and go onto the core. This is how the factory builds its graphite blades, whether mass-producing amateur sticks or making a few special-order sticks for a pro player. At this point, retail sticks head into large-scale automated production. Workers continue making pro sticks by hand. Initially, they produce a customized wooden mold for each player's stick and give it an identification number to prevent mix-ups. They install this two-piece mold on a press. The press shapes the blade to the player's precise specifications for the face or vertical angle and the curve. This molding process also compresses the graphite layers into a single unit and bonds the blade to the shaft permanently. The plastic bag over the blade prevents excess resin from oozing all over the press. Using a router, they profile the blade to a specific shape. Each pro player orders his own personal template. It can be any shape, provided it abides by NHL regulations. Maximum curve, 19 millimeters, maximum height, 7.6 centimeters, and maximum length, 30 centimeters. Now, a good sanding and a thorough buffing. They dip the blades in urethane, a colorless coating that fills in tiny imperfections on the surface. Once that dries, a machine sprays silver paint at the base of the shaft. finally, another coat of urethane to seal and protect the paint. For the retail market, this company mass produces 6 models of graphite hockey sticks in a right-handed and left-handed version. They all have the same blade shape but different curves. You can peel off the removable model name decal and write your own name on the shaft instead. Not nearly as personalized as a made-to-order pro stick, but at least you won't leave the arena with someone else's hockey stick by mistake. The pitter-patter of little footsteps is a welcome sound in any household, but children grow by leaps and bounds. Bronzing baby shoes is one way to preserve the memory of those first steps. The tradition was started back in the 1930s, and it grew in baby steps. In these shoes, a child learned to stand on his own 2 feet. His baby shoes have joined a pile of others. They're all about to be preserved forever. They record information about the shoe's owners, including personal details for engraving. They assign a tracking number to each pair. Without it, some shoes might not find their way back to their owners. They stamp that number onto insoles. There's a special coating on the insoles that will prevent the metal plating from sticking to them, so this number will be visible throughout processing. They staple down the insoles and then dip the shoes in a special formula. It chemically seals them and will also help stiffen them as they dry later. But first, they hang them to allow excess liquid to drip off. They stuff each shoe with plastic to give it some shape. They push a rolled plastic form into each shoe to complete the shaping. They tie the laces, positioning the bows flat against the shoes so they won't break off during the rest of the process. As an extra precaution, they wrap a rubber band around each bow and then glue it down. With the shaping plastic removed and the shoes dried and stiffened, they drill holes into the bottom of the soles. This will allow them to be hung on prongs during plating later. But before that happens, they stir up a mix of water, copper, and other ingredients. They carefully submerge a rack full of baby shoes into the coppery liquid. This isn't the final coating. It's a key preparation step. It makes the shoes electrically conductive so that they can be electroplated. They hang the shoes to dry and dribble a little more of the liquid onto them to cover any bare spots. They allow the finish to dry for a couple of days. Then, a worker lowers them into the electroplating tank. An electrical current runs through the shoes, attracting copper in the tank to plate them. Using a special polishing wheel, they lightly scratch the bright copper finish on the shoes. This prepares them for the next step. They spray a black finish onto the shoes and then wipe it off, rubbing some into the crevices to give them an antique appearance. Next, they spray them with a protective lacquer. can still see the identification number clearly on the insole, so they haven't lost track of the owner. I guess it's one of ours. They attach the engraving plate onto a wood base and screw the shoes onto it. Now they won't be going anywhere except down memory lane. And it seems there's no end to the bronzed keepsakes that can also take you there, from cowboy boots to burgers on a bun. Treadmills were invented back in the 1800s for the farm team. Farmers put animals on treadmills to power butter churns and threshing machines. It wasn't until the middle of the 20th century that people started working out on treadmills, and as a fitness concept, it's been a runaway success. In these high-tech treadmills, computer processors assess your level of fitness and plot your workout program. To make one, they punch holes in aluminum frame side pieces. These holes will be used to attach other parts. But first, they weld joints to the side pieces. And they weld brackets onto the platform that will hold the treadmill's motor. They position the platform between two aluminum side pieces and screw it into place to complete the frame. Next, they attach the elevation mechanism. This piece will raise the treadmill belt. They fasten wheels to the frame that will allow the treadmill to be rolled away for storage. They turn the treadmill frame over and work on the underside. They attach brackets for the rollers that go inside the belt. Then they position the belt and deck over the frame. They slide in the steel rollers and attach the drive belt. They bolt a big shock absorber to the drive motor to dampen its vibration. They install a strobe disc and then place an optical sensor over it. With the help of this sensor, the strobe will monitor the motor speed 16 times per second. They mount the drive motor for the treadmill belt on the special platform and bolt it into place. At this point, they attach one of the computer boards. It receives information from the optical sensor about the treadmill's speed and relays it to the computer in the control panel. This will ensure that everything is in sync. Here, they slide a protective casing over the framework. They cap the ends, then turn the machine over once more to install the mechanism that allows the treadmill to be folded up when the workout is over. They screw a plastic cover onto it to protect the bottom. And it's over to the control system. They stick the control membrane onto the plastic housing and attach a safety switch to the back. Then they install the treadmill's other computer board in this housing. They plug a lead wire into the safety switch and install a receiver to pick up the runner's heart rate. They secure the handlebar assembly to the control housing and plug in the upper circuit board. Now they close the back of the control system, and it's time for the two assemblies to come together. They connect the upper and lower computer boards so they can communicate. And then they give the treadmill a little test run to make sure it's in top form. They put it through a range of elevations and check the belt to determine if it's running in the middle. They adjust the belt to center it a little better. And now this treadmill has passed inspection. So they wipe away their footprints and press the brand label onto the hood. They lower the hood onto the motor. And now this treadmill is ready to give you a good run for your money. Handhelds, as they're called, are rugged computers designed for workers on the move. You see them on delivery trucks, police cruisers, forklift trucks, and in large warehouses. They process data in virtually any condition, from bad weather to rough roads. So even though you're in the field, you're still plugged in. From scanning barcodes to reading parking meters, handhelds provide information on location. They start with the keyboard electronics panel. They test each contact for conductivity. Then they transfer the tracking number from the electronics panel to the inner casing, so it will be visible if it needs servicing. They glue the electronics panel to the casing with silicone for a waterproof seal. The rubber keypad goes on next. Then they glue a protective plastic plate over it. Next, they cut a silicone liner to the size of the computer screen. It will help seal the unit, preventing water and dust from getting in. They place the liner in a bracket behind the screen, and then use this jig to align the screen to the computer casing. A dab of thread locker glue to the screws helps to hold it all together. The top casing for this handheld computer is now assembled. They move on to the back casing and install a speaker. They apply a layer of silicone to a circuit board assembly, again to resist water and dust from seeping into it. This assembly goes into a hole in the back casing. It will allow the unit to communicate with the central computer. In the next step, they wire the speakers to the circuit board, and now the handheld has a sound system. More silicone on these connections. Then they install triggers for the scanner, one on each side. They install a liner on the door for the memory card compartment. Then they run the top assemblies for 3 hours in extreme temperatures. Once the inner workings have been completely installed, they attach the top assemblies to the bottom ones. They tuck the battery pack into its compartment and install the end cap. It has an antenna for wireless communication. Now they install a smart card reader, because this particular handheld computer will be used for security checks on personal ID cards. They test the laser scanner. Then activate security software, which reads fingerprints, allowing this handheld computer to do security or criminal checks on the spot. When an unregistered person presses a finger onto the print reader, this is what happens. Of course, mobile computers are designed to return to a home base, where they upload information to a main computer. But first, randomly selected units get roughed up in a series of tests. They toss this unit into a tumbler, and it gets thrown around. Then they drop it from a height of 2 meters. They plunge it into a tank of water. In the real world, things can be even tougher. This computer ended up in a fire. And this one was run over. But even when it seems that they've been completely destroyed, information can still be salvaged. Here they transfer the memory board from one of the wrecked units to an undamaged one. They hook it up to a central computer and retrieve the information. After all, these units are really all about the facts.